chapter we have studied what are vectors, different properties of vectors and the numericals relating vectors. Now we have to study the different quantities like displacement, velocity, acceleration, equations of motion, etc. in vector form. Now first one is position and displacement vector. Okay. Now consider an object moving in the xy plane. Here this is the xy plane. P and P dash be the positions of the object at time t and t dash. Let P be the initial position of the object and after a time P dash be the final point. So at time t P is the position and at time t dash P dash is the position. Clear? We join origin and the point by a straight line like this. We can join, this is the origin and the point P by a straight line. Then OP is the position vector. This OP represents the position vector of the object at time t. So position vector means from the origin to the point we can draw a straight line with an arrow. That is called the position vector. Now what is the position vector at the point P dash? That is from the origin to the point P dash we can draw a straight line. So this is the position vector at the point P dash. So OP and OP dash represents position vectors. Clear children? So let P and P dash be the positions of the object at time t and t dash. Vector OP is the position vector at time t and vector OP dash is the position vector at time t dash. So this vector OP is the position vector at time t and vector OP dash is the position vector at time t dash. And position vector is usually represented by R. Okay, so OP can be represented as vector R and OP dash can be represented as vector R dash. So at time t the position vector is vector R and at time t dash the position vector is vector R dash. So vector OP equal to vector R and vector OP dash is equal to vector R dash. Okay, so that is the position vector. Now what is the displacement vector? We know displacement is the shortest distance between the initial position and the final position. Here what is the initial position? P. What is the final position? P dash. So this P to P dash, this distance is considered as this distance from P to P dash. This is considered as the displacement vector. Okay, shortest distance from initial to the final position, this is considered as the displacement vector and displacement vector is usually represented as delta R. Okay, so initial position is vector R and final position vector is vector R dash. The shortest distance between the initial position and final position, that is P dash, is called a displacement vector. So displacement vector is, what is displacement vector in this case? Displacement vector is P dash. Okay, vector P dash. So the tail is at the initial position and the head is at the final position. That is the usual method. Tail at the point P and head at the point P dash. So displacement vector is P dash and it can be represented as delta R. Clear children? Now we can see how we will represent the position vector in resolved form. Let P be the position of the object. OP represents the position vector, isn't it? Now the position vector, we know that it is represented by vector R. Now how will you represent this position vector in resolved form? So here this is its x component. We can draw its x component like this. This represents the x component of the object or the position of the object and this represents the y component. Isn't it children? So this is x component and this represents a y component. X component is represented like this, x I cap, and here the y component is y j cap. Usually any vector, we know that any vector in resolved form, for example vector A in resolved form can be written as ax I cap plus ay j cap. We are discussing motion in a plane, no? So consider only the two dimensions, x I and j. So vector A in resolved form is ax I cap plus ay j cap. Similarly, vector R in resolved form can be written as, what is vector R in resolved form? Rx I cap plus ry j cap. Okay, what is Rx? The distance along the x direction. What is Ry? Distance along the y direction. Okay, so here Rx is usually represented as What is Rx is equal to X. What is Ry? It is usually represented as Y. Okay, so position vector is not represented as R equal to Rx I cap plus Ry j cap. Position vector is represented as, position vector can be represented as, position vector can be represented as vector R equals Rx. Rx is X. So, X I cap plus Y j cap. So, no need to represent position vector as Rs I cap plus Ry j cap. Position vector is usually represented as X I cap plus Y j cap. Similarly, the position vector R dash. How will you represent vector R dash? Vector R dash can be written as X dash I cap plus Y dash j cap. Okay, children. So, initial position vector can be represented as vector R equal to X I cap plus Y j cap, and the position vector at time t dash can be represented as vector R dash equal to X dash I cap plus Y dash j cap. Okay, so this is the usual representation of position vectors. Now, we know displacement vector is, what is displacement vector? Displacement vector is final position minus initial position, that is vector OP dash minus vector OP, or displacement vector is usually represented as delta R, isn't it, is equal to vector R dash minus vector R. Clear, children? Now, how will you represent vector R dash in resolved form? We know that it is X dash I cap plus Y dash j cap. What is vector R in resolved form? X I cap plus Y j cap. So, it can be written as X dash minus X into I cap, isn't it? X dash minus X into I cap plus Y dash minus Y into j cap. We know that displacement vector is R dash minus R. Similarly, X dash minus X is delta X I cap plus what is Y dash minus Y? Delta Y j cap. So, how will you represent displacement vector in resolved form? Delta R equals, vector delta R equals delta X I cap plus delta Y j cap. So, this is the representation of displacement vector in resolved form, vector delta R equal to delta X I cap plus delta Y j cap. Now, we can study velocity vector. So, in the chapter motion in straight line, we have studied what is velocity. Velocity is displacement divided by time. Here we can represent velocity in vector form. Okay. So, velocity vector is represented by vector V. We know velocity vector is displacement vector divided by time. Okay. So, velocity is displacement by time and velocity vector is displacement vector divided by time. What is displacement vector? We know that it is delta X I cap plus delta Y j cap divided by delta t is equal to, what is, we can separate this delta t. So, delta X by delta t into I cap plus delta Y by delta t into j cap. Okay. What is delta X by delta t? That is displacement along x direction divided by time. Displacement by time along which direction? X direction. That is velocity. Velocity along x direction into I cap. What is delta Y by delta t? That is displacement by time along which direction? Y direction. That is Vy j cap. So, how will you represent velocity in vector form? Vx I cap plus Vy j cap. Okay, children. So, velocity is displacement vector divided by time. Displacement vector, we know it is delta x I cap plus delta y j cap divided by delta t. We can separate it, delta x by delta t I cap plus delta y by delta t j cap. What is this delta x by delta t? Displacement by time along x direction, that is Vx I cap plus delta y by delta t is velocity along y direction, that is Vy j cap. Hence, velocity vector can be represented as vector V equal to Vx I cap plus Vy j cap. Now, the third one is acceleration vector. Acceleration vector is represented by vector A. We know that acceleration is this velocity, change in velocity Now the third term is acceleration vector. We know acceleration is rate of change of velocity. Velocity, change in velocity divided by time is acceleration. Similarly, acceleration vector can be written as vector A equal to change in velocity, that is delta V divided by delta T. Clear? The change in velocity divided by time. What is delta V? We know that vector V equal to Vx I cap plus Vy j cap. Similarly, we can substitute delta V can be written as Vx I cap plus Vy j cap divided by delta T. Okay, delta represents the change is equal to, we can write delta Vx I cap by delta T plus delta Vy j cap divided by delta T. What is this delta Vx by delta T? Change in velocity along x direction divided by time. That is actually what? That is actually the acceleration. Change in velocity divided by time is acceleration. Since it is along the x direction, we can represent it as Ax. I cap plus what is delta Vy by delta T is Ay j cap. So acceleration can be written as vector A equals Ax I cap plus Ay j cap. This is the representation of acceleration in vector form. Now we can discuss equations of motion in vector form. Suppose an object is moving in xy plane and its acceleration A is a constant. We have the first equation v equal v0 plus at, where v is the final velocity, v0 is the initial velocity, a represents the constant acceleration and t represents the time. And in vector form it can be represented as vector v equals vector v0 plus vector a into t. Now in resolved form, this vector v can be written as vx I cap plus vy j cap equals, how will you represent vector v0 in resolved form? v0 x I cap plus v0 y j cap. Okay, plus how will you represent vector a in resolved form? ax I cap plus ay j cap into the time t. Time t is a scalar quantity. Now we can separate the x components and y components. So how will you represent the x component? X component can be written as Vx equals here. Vx equals here, what is x component? V0x plus here what is x component? Ax into t. We can separate the x component. So this represents the x component. And how will you represent the y component? Take the j cap vectors. Okay. So here it is Vy equals here V0y plus Ay. So this is the representation of first equation of motion in vector form. Now we can represent the second equation. Second equation is S is equal to V0t plus half at square. This is the second equation. In vector form, displacement is usually represented by delta r, isn't it? Displacement is represented by delta r. Equals here in vector form means V0 represents a vector, t plus half a is a vector, therefore vector a into t square. Now in resolved form, this delta r can be written as, we know it is delta x I cap plus delta y j cap equals vector V0 in resolved form is V0 x I cap plus V0 y j cap into t plus half vector a in resolved form is ax I cap plus ay j cap into this t square. Okay, now the x component can be written as, x component is here, take I component terms, I terms together. So we can write delta x equals V0 xt plus half ax t square. And how will you represent the y component? Y component is delta y equals V0 yt plus half ay t square. This is a representation of second equation of motion in vector form. Now we can represent third equation of motion in vector form. We have the third equation v square minus v0 square equal to 2as. Here s can be represented as delta r. Okay, delta r represents the displacement vector. Here we can separate x component. Similarly, we can write, similar to the first equation and second equation, we can write x component as vx square minus v0 x square equal to 2ax delta x, isn't it? Delta represents the displacement vector, its x component is delta x. And how will you represent the y component? vy square minus v0 y square equal to 2ay into delta y. So, this is the method of representing the third equation of motion in vector form. Okay children.